Hello, PyTexas. It's Pandy Knight here. I'm the Automation Panda, and I'm a huge Python fan, just like y'all. Have you ever seen those @ tokens on top of Python functions? Perhaps you've seen them on top of classes and methods as well. Those are decorators, one of Python's niftiest language features. Decorators are essentially wrappers. They add additional code to existing definitions. When used properly, they can clean up your code better than OxyClean. So today, let's learn how to use decorators.
So, here's a regular old hello world function. When we run it, it prints hello world. Nothing fancy here. Now, let's take that function and bam, add a decorator to it. Using this @, we just added a decorator named tracer to hello world. So, what is this decorator? Tracer is just another function, but it's special because it takes in another function as an argument. Since tracer decorates hello world, the hello world function is passed into tracer as an argument. Wow! So, what's inside tracer? This decorator has an inner function named wrapper. Can you even do that? With Python, yes you can. The wrapper function prints entering, calls the function originally passed into the decorator, and then prints exiting. When tracer decorates hello world, that means hello world will be wrapped by entering and exiting print statements. Finally, the decorator returns the new wrapper function. Anytime the decorated function is called, it will effectively be replaced by this new wrapper function. So, when we call hello world, the trace statements are now printed too. Wow, that's amazing. That's how decorators work. Decorators wrap functions around functions. Think about them like candy bars. The decorator is like the foil wrapper, and the decorated function is like the chocolate or the candy bar inside. But how is this even possible? That decorator code looks confusing. Decorators are possible because in Python, functions are objects. In fancy language, we say functions are first-order values. Since functions are just objects in Python, we can pass them into other functions as arguments, define new functions inside existing functions, and return a function from a function. This is all part of a paradigm called functional programming. Python supports functional programming because functions can be treated like objects, and that's awesome. So, using functions as objects, decorators change how functions are called. Decorators create an outer decorator function around an inner decorated function. Remember, the outer function is like the foil wrapper, and the inner function is like the chocolate. Creating an outer function lets you add new code around the inner function. Some people call this advice. You can add advice before or after the inner function. You could even skip the inner function altogether. The best part is, decorators can be applied to any function. They make sharing code easy so you don't repeat yourself. Decorators are reminiscent of a paradigm called aspect-oriented programming, in which code can be cleverly inserted before and after points of execution. Neat! So remember, decorators wrap functions around functions, like candy bars. Hold on now. I think we have a problem in that Python code. If the wrapper function effectively replaces hello world, then what identity does hello world report? Unfortunately, its name is wrapper, and its help is also wrapper. That's not right. Never fear, there's an easy solution. The FuncTools module provides a decorator named wraps. Put functools.wraps on the wrapper function and pass in the inner function object. And decorated functions once again show the right identity. That's awesome. But wait, there's another problem. How do decorators work with inputs and outputs? What if we decorate a function with parameters and a return value? If we try to use the current tracer here, we'll get an error. Arguments broke it. But we can fix it. First, add star args and star kw args to the wrapper function's parameters, and then pass them through to the inner function. This will make sure all arguments go through to the decorator, or through the decorator into the decorated function. Then, capture the inner function's return value and return it from the wrapper function. This makes sure return values also pass through. If the inner function has no return value, don't worry. The decorator will pass through a none value. When we call the function with the updated tracer, we see tracing is now successful again. And when we check the return value, it's exactly what we expect. It works. Wow, that's awesome. But wait, there's more. You can write a decorator to call a function twice. Start with the decorator template and call the inner function twice. Return the final value for continuity. And bam, it works. But wait, there's more. You can write a timer decorator. Start with the template, call the inner function, and surround it with timestamps using time module. Here, we capture the start time and the end time, and then we'll just print the difference. Bam! Now you can time any function. But wait, there's more! You can add more than one decorator to a function. This is called nesting. Order matters. Decorators are executed in the order of closeness to the inner function. So, in this case, call twice is applied first, and then timer is applied. If these decorators are reversed in order, then each inner function call is timed. That's pretty cool. But wait, there's more. You can scrub and validate function arguments. Check out these two simple math functions, add and subtract. Create a decorator to scrub and validate inputs as integers. Add the wrapper function and make sure it has positional args. Then cast all args as ints before passing them into the inner function. Here, we're using a list comprehension to do that integer conversion. Now, when those math functions are called, all numbers are integers. Using non-numeric inputs also raise a value error. But wait, there's more. You can create decorators with parameters. Here's a decorator that will repeat a function 5 times. The repeat function is a little different. Instead of taking the inner function object, it takes in the parameter, which is the number of times to repeat the inner function. Inside, there's a repeat decorator function that has a parameter for the inner function. The repeat function returns the repeat decorator function. Inside repeat decorator is the familiar wrapper function. It uses FuncTools wraps, and it passes through all arguments. Repeat decorator returns wrapper. Finally, wrapper contains the logic for calling the inner function multiple times, according to the repeat decorator's parameter value. That's that for loop. For blank in range, call the function with the arguments. Now, the hello world function runs 5 times. Nifty. But wait, there's more. Decorators can be used to save state. Here's a decorator that will count the number of times a function is called. Count calls has the standard decorator structure. Outside the wrapper, a count attribute is initialized to 0. This attribute is added to the wrapper function object. Remember, we can do that in Python because attributes can be added to objects at any time, and functions are just objects. Inside the wrapper, the count is incremented before calling the inner function. The count value will persist across multiple calls because it's attached to that function object. So here we see an initialization and then per call an increment. Initially, the hello world count value is 0. After 2 calls, the count value goes up, as expected. That's pretty awesome. But wait, there's more. Decorators can be used in classes. Here, the timer decorator is applied to this hello method. As long as parameters and return values are set up correctly, decorators can be applied equally to functions as well as methods. Interestingly, decorators can also be applied directly to classes. When a decorator is applied to a class, it wraps the constructor, as shown here. Since we've added timer to greeter, it'll print the elapsed time whenever the greeter constructor is called. Note, however, that decorators on a class do not wrap each individual method in the class. That's a common misconception. If you want to wrap methods in a class, you need to apply decorators directly to those methods. Since decorators can wrap classes and methods in addition to functions, it would technically be more correct to say that decorators wrap callables around callables than simply to say decorators wrap functions around functions. Nevertheless, we can be a little bit liberal in our use of the word functions. So all that's great, but can decorators be tested? Good code must arguably be testable code. Well, today's your lucky day, because yes, you can test decorators. Testing decorators can be a challenge. We should always try to test the code we write, but decorators can be tricky. Here's some advice. First, separate tests for decorator functions from decorated functions. For decorator functions, focus on intended outcomes. Try to focus on the wrapper instead of whatever inner function is decorated. Remember, decorators can be applied to any callable, so cover the parts that make the decorators unique. Decorated functions should have their own separate unit tests. Second, apply decorators to fake functions used only for testing. These functions can either be simple functions that are created inside a test module, or even mocked functions. That way, unit tests won't have dependencies on existing functions that could change. Tests will also be simpler if they use slimmed down decorated functions. Remember, simple is better than complex. Third, make sure decorators have test coverage for every possible way they could be used. Cover decorator parameters, decorated function arguments, and return values. Make sure the name and help are correct. Check any side effects, like saved state. Try it on methods and classes, as well as functions. With decorators, most failures happen due to overlooked edge cases. Let's look at a few short decorator tests. We'll use the count calls decorator we saw earlier. Here, there are two decorated functions to use for testing. The first one is a no-op, or a no-operation function, that basically does nothing. It has no parameters or returns. The second function takes in one argument and returns it. Both of these functions are very simple, but they represent two equivalence classes of decoratable functions, so it's worth having both in our unit tests. The test cases will verify outcomes using the decorator. For count calls, that means tests will focus on the count attribute added to the decorated functions. This first test case here simply verifies that the initial count value for any function is 0. The second test calls a function 3 times and verifies that its count is 3. The third test exercises the same function to make sure arguments and return values work correctly. It calls the same function, asserts the return value, and then asserts the count value. This collection of 3 tests is by no means complete. It simply shows how to start writing tests for decorators. It also shows that you don't need to overthink unit tests for decorators. After all, simple is better than complex. Up to this point, we've covered how to write your own decorators. However, Python has several decorators available in the language and in various modules that you can use absolutely free. Decorators like class method, static method, and property can apply to methods in a class. Frameworks like Flask and pytest have even more decorators. Let's take a closer look. Let's start by comparing the class method and static method decorators. These are part of the Python standard language. We'll revisit the greeter class we saw before. The class method decorator will turn any method into a class method instead of an instance method. That means this hello method here can be called directly from the class itself instead of from an object of the class. This decorator will pass a reference to the class into the method, so the method has some context of the class. Here, the reference is named CLS, and the method uses it to get the class's name. The method can be called using greeter.hello, and as we see, the name is substituted in the output. Wow! The static method decorator works almost the same as the class method decorator, except for one small difference. It does not pass a reference to the class into the method. Notice how the method parameters are empty. No class and no self. Methods are still called from the class, like here with greeter.goodbye. You could say that static method is just a simpler version of class method. And either of these decorators could be applied to any methods in your class. Just be smart about what you want to do. Next, let's take a look at the property decorator. To show how to use it, we'll create a class called accumulator to keep count of a tally. Accumulator's init method initializes a count attribute to 0. An add method adds an amount to the count. So far, nothing unusual. Now, let's add a property. This count method has the property decorator on it. This means that count will be callable as an attribute instead of a method, meaning that it won't need parentheses. It is effectively a getter. The calls to count in the init and add methods here will actually call this property instead of the raw variable. Inside the count property, the method returns an attribute named underscore count. The underscore means that this variable should be treated as a private variable. However, this class hasn't set that underscore count variable yet. That variable is set in the setter method. Setters are optional for properties. Here, the setter validates that the value is set, or the value to set is not negative. If the value is good, then it sets underscore count. If the value is negative, then it raises a value error. Underscore count is handled internally, while count is handled publicly as the property. The getter and setter controls added by the property decorator let you control how the property is handled. In this class, the setter protects the property against bad values. So, let's use this class. When an accumulator object is constructed, its initial count is 0. After adding an amount to the object, its count goes up, as expected. Its count can be directly set to non-negative values. Attempting to set the count directly to a negative value raises an exception, as expected. Protection like that is great. Python packages also frequently contain decorators. That's why it's very important that you know how decorators function before you go consuming a whole bunch of really cool packages out there. For example, Flask is a very popular web micro-framework app that enables you to write web APIs with very little Python code. Here's an example Hello World Flask app taken directly from the Flask docs online. It imports the Flask module, creates the app, and defines a single endpoint at the root path that returns the string hello world. Flask's app.root decorator can turn any function into a web API endpoint. That's awesome, and that's why a lot of people love using Flask. Another popular Python package with decorators is pytest, Python's most popular test framework, and to be honest, one of my favorite test frameworks in any language. One of pytest's most beloved features is the ability to parameterize test functions to run for multiple input combinations. Test parameters empower data-driven testing for wider test coverage. To show how this works, we'll use a simple test for basic arithmetic. Test addition. It asserts that A plus B equals C. The values for A, B, and C must come from a list of tuples. For example, 1 plus 2 equals 3. 0 plus 1 equals 1, and so on. The pytest mark parameterize decorator connects the list of test values to the test function. It runs the test once for each tuple in the list, and it injects the tuple values into the test case as function arguments. This test case would run 4 times. Test parameters are a great way to rerun test logic without repeating test code. So, act now before it's too late. When should you use decorators in your Python code? Use decorators for aspects. An aspect is a special cross-cutting concern. They are things that happen in many parts of the code, and they frequently require repetitive calls. Think about something like logging. If you want to add logging statements to different parts of the code, then you need to write multiple logging calls in all those places. Logging itself is one concern, but it cross-cuts the whole code base. One solution for logging could be to use decorators, much like we saw earlier with our first tracer decorator. Good use cases for decorators include logging, profiling, input validation, retries, and registries. These are things that typically require lots of extra calls inserted in duplicative ways. If you're considering whether or not you should use a decorator, ask yourself this. Should the code you're writing wrap something else? If yes, then you have a good candidate for a decorator. However, decorators aren't good for all circumstances. You should avoid decorators for main behaviors, because those should probably be put directly in the body of the decorated function instead of in a separate wrapper. Avoid logic that's complicated or has heavy conditionals too, because simple is better than complex. You should also try to avoid completely sidestepping the decorated function. That could really confuse people. So ask yourself this. Is the code you want to write the wrapper or the candy bar itself? Wrappers make good decorators, but candy bars do not. I hope you found this infomercial about decorators useful. If you want to learn more, check out this real Python tutorial by Geir Arne Kjell named Primer on Python Decorators. It covers almost everything I shared here, plus more. Thank you very, very much for listening. I really appreciate you taking the time to listen to this talk on decorators. Again, my name is Pandy Knight. I am the Automation Panda and a bona fide Pythonista. Please read my blog at automationpanda.com and follow me on Twitter at automationpanda. I'd love to hear what y'all end up doing with decorators. So thank you and enjoy the rest of PyTexas 2020.